Hello, my name is Adrian and we would just like to introduce a short section on SGN's perspective on WLR. I've been in the gas industry since I got thrown out from school, which is a very long time ago, and we would like to talk about a few topics on WLR in the next 20 minutes or so. Generally about WLR, a bit of background on the gas industry, where it is that we use these products, the scale of the challenge, and lastly, what happens if it does go wrong. So now I'd like to hand over to my colleague Chris Thompson, who's going to talk about what is WLR. Over to you, Chris.
Thanks, Adrian. So WLR, so Openreach is, as it says there, modernisation of the UK phone infrastructure. The actual impact of it is that they will be retiring services from their product offering, namely ISDN, PSTN, and a number of copper-based products that you may not or may not be aware of. So it's the PSTN that and the ISDN we're focusing on as an impact to the gas industry. They will cease to be products as of December 2025, and we'll actually struggle to purchase any new ones after December 2023. There are stop sell notices already on 117 exchanges across the UK, and the replacements for these terminations are digital IP technologies. So based on fibre to the premises as part of the UK-wide fibre rollout, but also where that's impossible, there are also fibre to the cabinet services which will use a type of DSL type services to get you service. The size of this for Openreach is massive. They have 16 million lines they need to change and to swap over, and they are going gangbusters at it. COVID-19 has not slowed them down. In fact, it is actually helping them. And this will impact you. It will impact your home phone if you have a PSTN line. And so be aware and be ready. The gas transmission and distribution networks have evolved together over many years, and they are architected and rely on PSTN to keep them operational. We're challenged at the moment to find direct replacements for many of the use cases where we use these services, and the loss of this PSTN connectivity creates a commercial and safety risk for the UK gas industry. We are conducting trials in one of the early adoption sites in Salisbury. We're working with industry and with our other partners in electricity and gas to identify products and vendors who can help us. And a similar activity is happening in Mildenhall with the power guys are running trials there. So we're attempting to address the gaps and trying to find technologies and providers who can help us over the next 5 years to deploy solutions that are going to help fill the gap when we lose these core and critical capabilities that are currently delivered over this PSTN network.
Okay, so I'd like to give a bit of background on the UK gas industry. There are two parts. The first is owned by National Grid, and this is the motorway network of big pipes around the UK, supplying all of the gas distribution networks. Gas distribution networks work in their own geographical area, and they supply around 27 million customers with gas through 275,000 kilometres of pipe. We don't own the gas meters, and we certainly don't service gas appliances. We maintain, operate, manage the gas pipeline infrastructure that leads to every UK residence. So the GDNs sit at the tail of the network. We take gas from the National Grid's transmission network. We have to forecast how much gas we require from National Grid, and we're strictly governed by operating rules, because if we do things wrongly, it will jeopardise National Grid's system. We have to ensure that we meet a minimum pressure at every single house. In terms of criticality, gas infrastructure supplies very nearly half of the electricity that's generated. So without a gas, the whole UK infrastructure would cease. In our above 7 bar networks, this is our high pressure pipes. This is the system that delivers data into our SCADA application. It's used so that we can monitor our high pressure systems for faults, and it connects our very remote gas sites to our control centres. Telemetry has been around for longer than I have, over 50 years. It's been in operation, consists of lots of different systems, surprise, surprise. But importantly, it's used to monitor the gas quality into SGN's network, which ensures that the gas is safe to burn, because as gas comes out of the ground, it varies in quality, and we need to ensure that it is safe. Also, this copper infrastructure is used to generate gas bills. Here's what SGN's telemetry looks like at the moment. So most of our sites connect via satellite to our primary and secondary control centres, but we also have PSTN and ISDN connectivity to ensure that we have resilient connections to these most critical sites. Here's a picture of a typical pressure reduction site, which in this case reduces pressure from 40 bar to 2 bar. We have around 600 of these in SGN. Most of them use UHF radio or satellite to communicate. Below 7 bar, so this is smaller pipes around towns and cities. Here's examples of our hardware. Lots of this connects via PSTN circuits, and we have a huge number of these sites that need to connect. They're primarily all in PSTN, as I've mentioned, but of course the interesting thing is that none of these sites have electric power supply, because we don't like to mix gas and electricity. It's not a healthy mixture and needs to be done under very controlled conditions. So now I'd like to hand back to Chris.
Thanks, Adrian. So what are the challenges? As Adrian's just said, obviously gas is explosive. So a lot of the products we have to deploy have to be ATEX compliant. We need to either have barriers between our active equipment and the gas equipment, or they have to be intrinsically safe. So this is where some of our challenges differ from those of the electricity or indeed the water industry. Water luckily doesn't explode. Well, limited availability of gas has just been mentioned. Sorry, start again. So the presence of gas obviously causes a risk of explosion, and so our equipment needs to be ATEX rated. A lot of our stuff is zone 1 or 2, and we either have to introduce barriers between active equipment and the gas equipment, or have intrinsically safe electronics at the site. The limited availability of electricity at the sites, especially the small ones, is an issue. It drives an extensive use of battery technology, and also we've been doing some trials with solar panels, but they attract some unwanted attention sometimes, and also getting planning for them is sometimes difficult, certainly in larger metropolitan areas. The remote nature of some of the larger gas sites from the telephone exchanges also limits the availability of things like DSL or the replacement SGN services that are being proposed by OpenReach. And obviously, if they're going to move us to a fiber-based service, then the cost of ploughing fiber to a location can also become unrealistic. We have physical size limitations, as you saw in some of those pictures. We may have a space size of a small briefcase with which to fit everything. And so that gets in the way of a lot of our installations. And also, though, we have a lot of subground installs where all sorts of materials get washed into those, and obviously dust, dirt, water is something that electronics don't usually mix well with. So we need these things to be IP67 at least. We do suffer from vandalism like everyone else, so anything that is conspicuous will get played with and stolen or broken off. And the other challenge is that we have a low concentration of sites, but we are at the same time spread out over a wide geographic footprint. So that can sometimes offer economy of scales and challenges for people trying to offer us solutions that the densities there are not really supportive of some commercial products. I suppose the other side of it is sort of ties into that is the numbers of sites that we have compared with our electricity colleagues is pretty small. However, they're significant enough to require an awful lot of effort and time to actually get them replaced. Obviously, the same as everyone else in this industry, we need to have engineering oversight. We need to test and validate. There is the risk that we could hurt people if we do things incorrectly. And obviously, anything that revolves around doing some physical work with either digging up the road or with installing large equipment is going to focus on licenses and potentially planning applications, etc., which takes time. The other thing that is sort of become apparent is that obviously we're all in the same boat. The gas distribution networks, the electricity utilities and transmission guys, etc. We're all doing the same thing, and we've all got to achieve it within the same short timescale. And there are a limited number of people who can do a lot of this work, and we're all going to be drawing on that same ecosystem to actually complete the activities that need to happen as part of WLR. So that's also going to be a challenge. We run the risk of fighting each other for the same resources. And as I said before, the WLR turnoff, the stop cells are being announced. They're being announced on a per exchange. They're not starting in the bottom left-hand corner and moving to the top right. They are random. And so that in itself doesn't lend itself to a linear program of work. And so trying to have an efficient change plan that follows a rather erratic trigger is going to be a problem for us. And it's going to hit our target of site per day conversion rates required to meet the December 2025 deadline. So from a scale point of view, as I say, we're not in the hundreds of thousands like the electricity guys are, but there's still significant numbers. So I think this adds up to 27,585. But if we look at that as a whole, then as an industry, as a gas network industry, that is an extensive amount of work that is going to take all of the 5 years available and more. It's going to need a huge team to achieve it. It's also going to obviously cost a lot of money. And the other thing to think about is the amount of change that is going to be driven by this activity in the gas distribution networks. I think it works out, if we started on the 1st of October, which we're a little bit behind that, we need to be converting 14 of these sites every day for the next 5 years to be able to hit that termination date of December 2025. And that is an awful lot of change in a utility network, and it may not even be sustainable. It's something that we're going to be challenged to achieve. So the other challenges are we don't have replacement products I think the WLR has been the best kept secret up until very recently. It's been talked about for nearly 10 years, but it's only really now becoming a reality. Everyone's been kicking that can down the road, and specialist suppliers that we use are still developing products. Power is the huge problem. At the moment, we utilize the 50-volt DC that comes down the PSTN line. So that's why when you have a power cut, your traditional phone still works. It's because it's actually powered from the exchange. And we rely on that power to supply our loggers and other equipment at site. And it's been very convenient. But as I say, the system has been architected with the PSTN in mind. So the additional challenges are that we don't have replacement products, and power. Power at the sites is a big issue for us. As I say, we use a lot of batteries that need to be replaced. We actually utilize at many of our sites the 50-volt DC that comes down the PSTN line, and that has been a luxury we've enjoyed for a number of years. That is going away, and so we need to find products that can run on batteries for extended periods of time, 6 months or more, and still power the gas equipment, but also the telecommunications equipment. From a financial point of view, we're regulated by Ofgem. We, as everyone does, we're entering in the end of our GD1 period, pricing control period. We're going to be moving into GD2 in April 2021. So this activity is falling between those pricing control periods, and as you can imagine, this sort of thing is falling between those gaps. We're not enough money in GD1, and have we allocated enough money in GD2? So finances is going to be a challenge for us in the coming years. From a numbers point of view, as I mentioned earlier, here's just a bit of the scale of it. So this is measured from the 1st of October. So 1,917 days until the switch off is completed. 1,200 days until the published UK-wide stop sell. That means we will not sell you any more ISDN, PSTN, and the other impacted services after that date. We've got 271 days until the Salisbury service retirement. So Salisbury stop sell was announced June last year, and at the end of June 2021, services that are not converted to the fibre will be retired. So we have a challenge there. And as I said before, there's 117 additional exchanges that have announced their stop sell as of today, and there will be additional exchanges announced every quarter up until the 2023 date. So this is coming to an exchange near you very, very soon. So we need to be completing 14 site conversions. We're already behind. We should have started years ago. But even if we started on the 1st of October, that's the number we should have been achieving. Based on some numbers between a number of the GDNs, the average cost is around about £7,000 per site to migrate. This is really basing it on the larger number of smaller sites where we have loggers and telemetry on those loggers, and we have to upgrade the communications modems. We can't afford to change the loggers. We have to swap the modems that attach to them. And when you extrapolate that out, that's a £211 million project. 31,500 estimated man days, and just to incentivize us, we utilize ISDN lines for some of our biogas facilities that are out usually on farms and out in remote sites, etc. And the latest cost for an ISDN circuit we were quoted was £200,000 to get it installed. Now, obviously, there's a challenge there. Obviously, this is a sunset technology. People don't want to do it, and they're not allowed to say no. But the costs for actually doing these things are being made unachievable. And ultimately, I suppose this cost of these projects and these activities are going to have to be paid for. So ultimately, this is going to roll back up and it's going to find its way back to the consumer somehow. We're not sitting here with a twiddling our thumbs, though. As I say, we are, as an industry, we're trying to work together. So all the GDNs are contributing. We're taking part in the STG and supplying them with information and supporting them in their challenging of the WL decisions and the timelines. We're creating opportunities for Openreach to come and talk to us, but to understand our challenges, but also to make sure and get Openreach in front of our suppliers so that they can also be made aware of what's going on. We've got trials in Salisbury and Mildenhall, and we're going to be inviting some partner organisations and some suppliers and the GDNs to try and test out some of the alternative products so that we can monitor power consumption and see ease of installation and test their suitability for use in the gas industry. We're challenging our service providers as well, saying, okay, what are you going to do? So a lot of those guys have got solutions, but unfortunately they are very consumer focused. They're not industry focused, and they certainly don't address the power challenges that we are seeing at some of our small sites. So we are going to be running some proof of concepts, and we've also been trialing some technologies and solutions ourselves at some of these remote sites, and they've highlighted that running things like cellular on batteries, even with a solar panel as an alternative power supply, is unachievable. And as I say, it says at the bottom there, we're behind the curve on actually getting those replacement products. So it's not unique to us. As I said, electricity, water, all the utilities are in a very similar position. I suppose the differences for us, as I said before, is our budget cycle. We've already gone through our draft determinations and are asking for money for our next pricing period. I think electricity go into theirs next year. We have our inherently explosive nature of what we do, so we have to be conscious of that. We can't use some products which other utilities can use. The smaller sites, which are number in their thousands, don't have grid power, and it's not going to be economic to put grid power into those locations, or sometimes even, as Adrian mentioned earlier, it's not even sometimes safe. And the remote natures of some of our facilities make DSL and SGN services uneconomic. The big impact on us, as I said, is the removal of the 50-volt DC. Battery power is going to, if we can't find low power solutions, is going to increase the number of site visits to replace those batteries, which has a knock-on impact of operational cost, and obviously increased environmental impact through additional travel, but also that brings risk to worker safety. The more miles you travel, the greater the risk of something unfortunate occurring, and having to do this maybe in bad weather, or at times when you would rather not be going out to a site in the remote reaches of Scotland. And as I said before, the cellular technologies are proving to be too power hungry for sites where we don't have mains power. So, and we've even, as I said before, we've been trialing some technology at site that to give us some more alternatives to our incumbent suppliers, but to achieve this on battery power is proving challenging. Now I'd hand back to Adrian.
Okay, thanks for that, Chris. That was brilliant. So now I'd just like to talk about why it's also necessary and what happens when it goes wrong. GDNs use SCADA to ensure the efficient and safe delivery of gas through the network. SCADA validates how the gas network is operating. It allows intervention via control systems to avoid alerts becoming incidents to ensure a continued gas supply. Gas control centres communicate with remote gas facilities via telemetry networks. Telemetry is positioned at key points in the gas network, at our offtakes and biogas sites, our network exit points, which is power stations and big gas users, our pressure reduction installations, PRSs, district governors, as we've mentioned, are in tens of thousands, and we monitor low points at the extremities. What happens if it goes wrong is that we suffer poor gas network management, which results in shrinkage, loss of gas. This can occur if we have to resort to the district governors working at a safe pressure, which is, in our words, in our language, is a high pressure rather than a low pressure, so that we ensure that the low point gets sufficient gas pressure, which can cause gas leaks along the pipes around streets. We can cause gas supply disconnections. If our high pressure metering information system is jeopardized, we can get poor gas quality results. And all of these cause risk to the environment and ultimately risk to life. So that's the conclusion of our SGN presentation. We'd like to thank JRC for the opportunity to present this information. We hope we've enlightened you. We hope we've scared you, because that was the idea. We certainly are. And so that's the end. And we'll look forward to some questions in the forum at the end. Thanks very much.